virtually, Takehiko Itoh.
I'll talk about analysis of photon radiation for spontaneous heat burst phenomena during hydrogen desorption from the nano-sized metal composites. We have observed anomalous heat generation phenomena by hydrogen desorption using nanostructured thin films. We installed nano-multi-layer films on the both sides of the heater with built-in thermocouples. This is placed in the vacuum chamber. And after hydrogen absorption, the nano-multi-layer film is heated up and to release hydrogen, thereby induced anomalous heat generations. Previous methods have evaluated excess heat using a thermocouple, but in recent years, more accurate evaluation has been attempted by measuring radiation from the surface. This figure shows the state of heat transfer when the heat generation occurs on the sample surface. Since our experiment is conducted under high vacuum condition, convection heat transfer can be ignored. Therefore, in addition to the thermocouple measurement, more accurate heat measurement is attempted by adding photon radiation from the surface. In tomorrow's session, Professor Kasagi will give a presentation on this. Next, I will about the aim of low energy photon observations. Our experimental method is characterized by the fact it is performed under vacuum condition, and that is, it uses thin films. Therefore, when anomalous heat generation phenomenon occurs, it is possible directly observe the photon radiation from the surface. We presume that this photon radiation is emitted with information related to the reaction. Detailed analysis of this radiation may provide information related to the reaction mechanism such as elementary reaction or hot spot size or location of the reactions. Therefore, we try to observe the low energy photons. Next, I explain low energy photons. High energy photons above 50 kiloelectron volt have not been observed in previous experiment. Usually, the reactant in stainless steel container and low energy photons are shielded and cannot be observed. But in our experiment, vacuum condition and under thin film, using the thin film, they are observable. The reason we attempted to measure the X-ray, visible light, infrared, and mid region, all of which have not been observed so far. And this is low energy photons we observed. Experimental procedure. Using a magnetron sputtering, nano-multi-layer film are formed. We set the sample on the heater and sample evacuation and baking. And next, we measure the heater temperature and photon radiation corresponding to the input power without hydrogen absorption. This is a reference experiment. And the next, we evaluate excess heat with this reference experiment. And next, we performed hydrogen absorption. After 12 to 15 hours, the experiment is started by evacuation and heat up samples. This is an experiment of heat. This is an example of heat burst. This figure shows that the time evolution of heater temperature and heater input. After hydrogen storage, we heat burst storage. We heat up the samples together with vacuum exhaust. Input power maintained 33 watts for 130 hours. In this experiment, spontaneous heat burst phenomena occurred. This is despite the constant heater input power, heat bursts were observed in which the heater temperature rose sharply by 10 degrees. There are multiple heat bursts observed. Such phenomena are often seen in our experiment. This figure shows the evaluation of excess heat. The baseline excess heat is about 2 watts, and further heat generation of about 1 watt is generated in heat burst. This is outline and a photograph for experimental equipment. 4 types of detectors installed to observe one side of the sample. Near infrared and visible light are guided by optical fiber through the focus lens. The spectrum measurement performed by FTIR and spectrometer. And mid-infrared light is measured by mid-infrared detector through the barium fluoride windows. And another mid-infrared detector is installed to observe the backside of samples. In addition, X-ray are observed by silicon drift detector through the beryllium windows. Mid-infrared light is measured by every second, and this spectrum of near-infrared and visible light was measured for 1 minute at the time, and the time interval is 5 minutes. This is the example of measurement light emissions. This is radiation from the standard sample using carbon nanotube. The emissivity is from 0.98 to 0.99, and it can be regarded as a black body. Therefore, the sensitivity of various measurement device was corrected using the distribution of black body radiations. This green area is mid-IR detectors, and the red region is near infrared region, and the blue is visible region we observed. So we are able to measure to a large part of the radiation of the light. And this is experimental results. This is the experimental results using copper, nickel, and calcium oxide multilayer films. The red line is heater temperature, and the black line is input power, and the green line is mid-infrared intensity. The hydrogen absorption was started at time 0, and 12 hours later, we evacuate and heat up the sample and kept the input power at 31 watt. We observed the heater temperature suddenly rose spontaneously, these red lines. And this spontaneous heat burst was observed 6 times in this experiment. The intensity of the mid-infrared rated also increased in synchronization with the burst, these green lines. Next, the result is visible light and near-infrared light add to the previous result and displayed. Visible light intensity, the blue squares, this blue squares is an integral of light of 1.6 to 1.8 electron volts. The red circle indicates the intensity of near-infrared light, which is an integral of 0.55 to 0.75 electron volt near-infrared light. It can be seen the visible light, near-infrared light, and mid-infrared light radiation increase synchronization with the heat burst. The comparison of the radiation spectra at time. This is spectra near-infrared and visible light before and during the heat burst. This figure is an enlargement of the time near the fifth burst. We compared two spectra at the immediately before the heat burst these times, and during the heat burst occurring these times we compared. This figure shows the spectrum comparisons. The blue circle is just before the burst, and the red circle is during the heat burst. When heat burst occurs, the light emission increases in synchronization with the heat temperatures and increases in the entire region from the infrared to the visible light. This suggests that sample has sudden energy generations which increase radiation power as well as the surface temperature, resulting in the rise of heat temperature. Next, we show the result of detail of the analysis of heat burst. This is the intensity of the light and the infrared intensity. This figure shows a correlation between near-infrared intensity and visible light intensity. There is a positive correlation between the intensity near-infrared and visible light. And the correlation appears three lines rather than one. This indicates the contribution of photon emission from the different reaction rates. And we grouped them in three colors to investigate what the three lines related to. As a result, it is found that three lines can be classified by grouping the burst. These three lines. The red line shows the fifth burst. The red line shows the fifth burst, and blue line is the first burst and second burst, and green line is other burst. This suggests that each burst is in a different reaction state, such as elementary reaction or hotspot size reaction region. Next, we investigate the difference in the distribution of light emission between different burst groups. First, we pick up the two different measurement times, burst 2 and burst 3, burst 5. In this figure, this time have almost the same near-infrared intensity, but different visible light intensity this time. And this point is this time point is burst and burst 5. We compare the spectrum these two times to confirm whether the light intensity is increasing in a specific energy region or in all regions. This is the result of a comparison of spectra two times. The intensity is almost same is near infrared region. The near infrared region is almost same. On the other hand, in visible light region, the burst fiber is increased with respect to the burst to over the entire measurement region. This is over the entire measurement region is increased. The intensity is particular energy region is not increased. The current measurement is as part of the radiation of light, and the full picture of have not been grasped yet. Therefore, in future, we would like to expand the measurement range and clarify the overall picture of the photon radiations, which will lead to the information to the reaction mechanism. Conclusion, using an optical measurement system, simultaneous detection of the light radiation was performed when heat burst occurred. When heat burst occurs, the emission of the light increase in synchronization with the heater temperature and increase the entire region from the mid-infrared visible light. And the correlation between the visible light intensity and near-infrared light intensity during the heat burst reveal different dependencies for each burst. This suggests the reaction state may be different for each burst. In future, we will expand the measurement range of emitted light that performed a more detailed analysis. Finally, I would like to thank for these stakeholders. Thank you.